Carbon dioxide (CO2) is not just an undesirable greenhouse gas, it is also an interesting source of raw materials that are valuable and can be recycled sustainably. In the journal Angewandte Chemie, Spanish researchers have now introduced a novel catalytic process for converting CO2 into valuable chemical intermediates in the form of cyclic carbonates. Getting CO2 to react is unfortunately not easy. Currently, most research is focused on the conversion of CO2 into methanol, which can be used as an alternative fuel as well as a feedstock for the chemical industry. Innovative catalytic processes could allow CO2 to be converted into valuable chemical compounds without taking a detour through methanol, perhaps for the production of biodegradable plastics or pharmaceutical intermediates. One highly promising approach is the conversion of CO2 into organic carbonates, which are compounds that contain a building block derived from carbonic acid, comprising carbon atom attached to 3 oxygen atoms. Researchers working with Angewandte at the Barcelona Institute of Science and Technology, Barcelona, the Institute of Chemical Research of Catalonia, Tarragona, and the Catalan Institute of Research and Advanced Studies, Barcelona, have developed a conceptually new process to produce carbon. These cyclic carbonates have great potential for the creation of new CO2-based polycarbonates. The starting materials are compounds with a carbon-carbon double bond and an alcohol group O on a neighboring carbon atom, homoallylic alcohols. In the first step of the reaction, the double bond is converted into an epoxide, a 3-membered ring with 1 oxygen and 2 carbon atoms. The epoxide is able to react with CO2 in the presence of a specific catalyst. The product is a cyclic carbonate in the form of a 5-membered ring with 3 carbon and 2 oxygen atoms. The carbon atom at the tip of the 5-membered ring is attached to an additional oxygen atom. In the next step, an organic catalyst N-heterocyclic base activates the O group and causes the 5-membered ring to rearrange into a 6-membered ring. The oxygen atom from the O group is integrated into the new ring, while one of the oxygen atoms from the original 5-membered ring forms a new O group. However, the reverse reaction also takes place because the original 5-membered ring is significantly more energetically favorable, and only a vanishingly small amount of the 6-membered ring is present at equilibrium. The trick is to trap the 6-membered ring. The new O group binds to a reagent acylation because its different position makes it considerably more reactive than the original O group. This newly developed process gives access to a broad palette of novel, 6-membered carbonate rings in excellent yields, with high selectivity and under mild reaction conditions. This widens the repertoire of CO2-based heterocycles and polymers, which are difficult to produce by conventional methods. Story source: materials provided by Wiley. Note: content may be edited for style and length. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you new tech videos. Thank you.